Ever wondered how a message from your device travels across the globe in mere seconds? It's a fascinating journey, and the magic behind it lies in the world of networks. A network, in the simplest terms, is a system of interconnected computers or devices. Imagine a bustling city where each building represents a device, a computer, a smartphone, a tablet, anything that can connect to the internet. Now, these buildings don't exist in isolation. They're connected by roads, bridges, tunnels, a complex web of pathways. In the world of networks, these pathways are the connections that link one device to another. Just like how people in a city exchange goods and services, devices on a network exchange data. This data can be anything: an email you're sending, a photo you're posting, or a song you're streaming. And the beauty of it is that this exchange isn't limited to devices in close proximity. A device in New York can communicate with another in Tokyo as easily as with one in the next room. Now you might be thinking, well, that's all well and good, but why should I care? Here's the thing, networks are everywhere. They're the backbone of the internet, the lifeblood of mobile communication, and the nerve center of home Wi-Fi systems. Understanding networks means understanding how our digital world functions. But how does this data travel across networks? Picture a highway. On this highway, data is broken down into small packets. These packets, like cars on a road, zoom across the network from one device to another. They might take different routes, but they all reach their destination, ready to be reassembled and presented to you in a form you can understand, be it a web page, a video, or a simple text message. So, a network is like a busy highway, with data packets zooming across from one device to another. But as we'll see in the next scenes, there's a lot more to the story. Who directs the traffic? How do the packets know where to go? Stay tuned as we unravel the mystery of networks. But how does this data know where to go? This is where net protocols come into play. Picture this. You're in a bustling city, trying to navigate the dense traffic. You need a guide, a set of rules, or better yet, a GPS system that tells you where to go, when to stop, and when to proceed. This, in essence, is what network protocols do for data on the internet. They are a set of rules that govern how data is sent and received over a network. Net protocols are like the GPS system for your data, ensuring it arrives at its correct destination. They dictate how data should be packaged, sent, received, and unpacked. Just as a GPS guides you from point A to point B, network protocols guide data packets from the source to the destination. These rules are crucial for a couple of reasons. First, they maintain order. Without protocols, the internet would be a chaotic mess, akin to a city with no traffic rules. Data would collide, get lost, or take forever to reach its destination. Secondly, net protocols prevent data loss. Imagine sending a crucial email, only to find out it never reached its recipient. Or consider streaming your favorite show, only for it to buffer endlessly due to lost data packets. Frustrating, right? That's what protocols save us from. They ensure that data packets reach their destination, and if they don't, they manage the retransmission of lost data. Finally, net protocols enable interoperability. They ensure that different devices, be it your smartphone, laptop, or smart fridge, can all communicate with each other seamlessly over the internet. They're the reason you can send an email from your iPhone and have it received on a Windows PC halfway across the world. So, the next time you send an email, stream a video, or simply browse the web, remember the invisible traffic police that make it all possible. The unsung heroes of the digital world, working tirelessly behind the scenes to ensure your data gets where it needs to go. In essence, net protocols are the traffic police of the digital world. Did you know there are different types of networks? Well, indeed there are, and each one has its unique characteristics and applications. Let's dive into this fascinating world and explore these types of networks. Firstly, we have local area networks, or LANs. As the name suggests, LANs cover a small geographical area, like a home, office, or a group of buildings in close proximity. They are typically used for connecting computers and devices within the same vicinity, allowing for resource sharing like printers or data storage. Next up, we have wide area networks, or WANs. These span a much larger geographical area and can extend across cities, countries, or even the entire globe. The internet is a prime example of a WAN, connecting billions of devices worldwide. Moving on, we have personal area networks, or PANs. These are intended for personal use within a range of about 20 meters. If you've ever connected your smartphone to a Bluetooth speaker, you've used a PAN. They're great for connecting personal devices like laptops, phones, and wearables. Lastly, we have metropolitan area networks or MANs. These are designed to cover an entire city or metropolitan area. They are used in large businesses, universities, or city councils to connect various LANs within a specific geographical area. Each network type has its own unique characteristics, uses, and range. LANs are ideal for sharing resources within a small area, while WANs allow for long-distance communication. PANs are perfect for personal device connectivity, and MANs are designed to cater to the needs of an entire city. So you see, networks are not all the same. They differ in size, range, and typical uses, each serving a specific purpose, from connecting your personal devices to linking computers across the globe. So, whether it's a small office or the entire world, there's a network for every scope.
You're probably using some of these net protocols right now, without even realizing it. Let's dive into the digital world and explore the unseen heroes that make your internet experience seamless. These heroes, known as net protocols, are essentially sets of rules that dictate how data is transmitted and received over the internet. First up, we have HTTP, or Hypertext Transfer Protocol. This little guy is responsible for most of the web content you see on your browser. Whether it's a news article, a social media post, or even this video, HTTP is the one bringing it to you. Next, there's FTP, or File Transfer Protocol. As the name suggests, FTP is all about transferring files. If you've ever downloaded a file from a website or uploaded photos to a cloud service, you've used FTP. It's like a digital courier, carrying your data to and from servers all over the world. Then we have SMTP, or Simple Mail Transfer Protocol. This is the protocol that makes email possible. It's like a digital postman delivering your emails from your outbox to the recipient's inbox. Without SMTP, you wouldn't be able to send those work emails or receive those newsletters you signed up for. Finally, there's TCP/IP, or Transmission Control Protocol Internet Protocol. This is the big one, the granddaddy of all protocols. TCP/IP oversees the entire operation, ensuring all data packets get to their destination and in the right order. It's like a traffic cop, directing the flow of data around the vast information superhighway that is the internet. Each of these protocols plays a crucial role in your daily internet usage. They work tirelessly behind the scenes, making sure your digital world runs smoothly. From browsing the web to sending emails to downloading files, these protocols are there, keeping the wheels of the internet turning. These protocols are the silent workhorses of your online world. They are the unseen heroes, making your digital life possible. So next time you're online, take a moment to appreciate the intricate ballet of protocols that makes it all happen. So, that's a whirlwind tour of networks and net protocols. We've journeyed through the labyrinthine realms of networks, unraveled their enigmatic nature, and discovered how they're essentially systems of interconnected devices, each playing a crucial role in the grand scheme of data transmission. In our quest, we learned that networks can be as small as two computers linked together or as vast as the global internet. We delved into the nuances of different types of networks, from local area networks that connect devices in close proximity to wide area networks that span large geographical areas. We also demystified the concept of net protocols. These invisible rulebooks guide every data packet in its journey from one node to another, ensuring that our digital communications are seamless and efficient. They're the unsung heroes of our digital universe, ensuring that every bit of data reaches its destination intact and in order. We've explored some of the most popular net protocols, shining a light on their unique roles and functionalities. We've seen how TCP/IP, the backbone of the internet, ensures that data is reliably transmitted across networks. We've looked at HTTP and HTTPS, the protocols that make the World Wide Web possible and are crucial for our online security. And let's not forget SMTP, POP3, and IMAP, the trio that ensures our emails reach their intended recipients. But our exploration is just the tip of the iceberg. The world of networks and protocols is ever evolving, with new technologies and standards emerging all the time. Each innovation brings us closer to a future where data transmission is faster, more secure, and more efficient. So, as we wrap up this journey, let's remember that every time we send a message, stream a video, or browse the web, we're relying on these complex networks and protocols. They're the invisible threads that connect us all, enabling our digital lives and shaping the future of communication. Next time you send a message or browse the web, spare a thought for the complex networks and protocols that make it all possible.